So when the demand factor is low, the less capacity of the system required to serve that connected load. If the demand factor is low, it seems that the less system capacity sufficient to drive that connected load. For a simple example, that I am having a shop which having one number of fluorescent fixtures, one number, 5 kilowatt each, and I am having some sockets, so with some 1500 watts, and I am having some air compressor, one number, and some pump I am having for the fire pump, which is 20 HP. Sorry, 20 of, let's take a 15 HP fire pump. So these are the loads I am having in my shop. Now I asked it, these are the equipments in the shop. Now, now the shop owner came to me and is asking, sir, could you please design the system for my shop? Then I'm asking the questions to that man, the shop. And he's given some information that the shop, the lights are only, the shop lights are only on during the hours of 8 a.m. to 5 p.m. He said that I will on the lights from 8 a.m. to the 5 p.m., sir. And I am having some receptacles. I don't know when I will use, I don't know that. And I am having the air compressor, supplies air onto the air tools and cycles of, suppose for a half of the time, like 12 hours, whatever it may be. And I'm having a fire pump that only runs 30 minutes once in a month. I will, that's just it's my prediction. Now I calculated the demand factor for this one. So what is the demand factor? I am running a 5 kilowatt of one for total, for a time period of, let's see, for the lighting, generally the demand factor will use the demand interval factor into the diversity factor. Generally, the diversity factor for the lights we will consider as 1. So the demand factor, mostly it would be 1. So 5 kilowatt into 1 gives me 5 kilowatt. And come to the receptacles, 1500 watts. Suppose I am having one receptacle, 1500 watts receptacle. So 1500 into what is again the demand factor for my receptacle. It's again depends upon the what is the diversity factor of the receptacle. The diversity factor into this interval gives me the demand factor of that receptacle, which is nearly, suppose, a 0.1, 0.2. The diversity factor for the receptacle is generally 0.1. So I'm multiplying 1500 into 0.1, will gives me some value. So at any case, I am multiplying this with some factor, which is a diversity factor. So now my question is, what is this diversity factor? Where I am multiplying this diversity factor with all these loads. For fans, for everything, there is some diversity factor. What is that? So let's see this. The diversity factor here is the sum of the individual maximum demand by maximum demand of the system. as I discussed it, I am having 10 fans, but I won't run the 10 fans at a time. I will on one fan from maybe at some from period of 6 a.m. to 7 a.m. Another fan will run at 10 a.m. to 12 p.m. Two fans. So there is some change in the maximum demand for a period of time. So what we're discussing, yes, demand factor and diversity factor, right? Yeah. So diversity factor is the sum of the individual maximum demand by maximum demand of the system. Like what is the installed load and what is the running load? What is the installed load and what is the running load? As similar, same, if you see this, it's similar to that. Installed load to the running load. Or the max, some of the, this is the one way of doing. Like other one is sum of the individual maximum demand by maximum demand of the system. Sum of the individual demand by maximum demand of the system. Generally, this diversity factor having, and if you see the distribution networks, for we are having so many different types of diversity factors as per if you just refer the standard of IEC 60439, you can find diversity factors for different cases. For the lighting, for the sockets, they are having their diversity factor. Suppose if you see the apartments, in that apartments, if the houses are if in the apartment if you are having 20 houses in that apartment, then it was recommended that take the diversity factor of 0.49. Cases like that. Suppose in a simple example, I'm having a 4-story building, and in the 4-story building, suppose I'm having 20 persons, 20 families are living in this. So each from each consumer, the demand is 6 kilowatt. So that what is the total installed load for the building? For the 20, suppose each 6 means. Let's suppose I'm having, we'll do here, then it would be good for you also to know. I'm having 6 customers, 4, 5, 6. The total installed load of the building, this is 36 kilowatt, 24 kilowatt, 30 kilowatt, 36 kilowatt, and 24 kilowatt. So suppose let's take this 36, 24, 30, 36, 4. Just if you sum it up, 150 kVA. So 150 kVA is the installed capacity of the system. Now, as I said, if I am having the these are the customers from each storage, 5 storage building. Suppose it's a 5 storage building. Each storage, this is the customer, 24 and 6. This. Let's see if I divide. I said before, each customer is having 6 kVA. Let's see how many customers are there. In this first floor, 6 persons, 4 persons, 5 persons, 6 persons, and 4 persons. 10, 10, 25. So 25 are the customers. So for the 25 customers in the IEC, as I said, 604439, they are having some tables. In that the diversity factor was recommended to consider some 0.46. So what is the here 150 into 0.46, which gives you 69 kVA. So the supply required for building is 69 kVA. So you can place the transformer with respect to this 69 kVA. If you take some margin, it would be quite good. That's it. No need to consider 150 kVA transformer. That is the beauty of this diversity factor. Now let's talk for our application.
Why you
Yeah,
are multiplying 0.46?
that is a factor, diversity factor. It is was recommended. See, to calculate like what is the diversity factor? Sum of the loads individual maximum demand by maximum demand. That gives you the diversity factor, right? That gives the diversity factor. Now, I know the maximum demand. So I just want the what are the loads that I can see maximum from each one. In the simple way, if you just recall our last statements, the diversity factor, one more example is installed. What is the installed load by running load? What is the installed load by running load into DF? So I have seen that the running load is this, and I'm multiplying with this, so I will get the installed load. Depends upon the diversity factor. So on this diversity factor, they will size the transformer or DG set in that apartments. If you design for the maximum load, it would be gives you a higher design of the transformer. Diversity factor is like how much amount of load that each consumer can have for some period of time, as we discussed it before, like continuous, non-continuous loads. Similarly, based on this, they provided the diversity, some of the values for the diversity factor. Not only this, based on the apartments. If you check that for the lighting, for the suppose if you're talking about the lighting loads, they will tell that consider the diversity factor as 0.9. Suppose if it is a main motors, large motors, they will tell us to consider the diversity factor of 1. That is a diversity factor.
Means when we go through any auxiliary load for auxiliary transformer purpose, at that time any specific chart is there to diversity factor per individual load wise, or in our design through that diversity factor will be calculated?
Yes, sir. Here again, two things are there. If you are not aware of the before the system, how it operates, how you don't know, you cannot judge the when the person in the suppose I'm having I have to give the supply to the 4 houses. I don't know how they are behaving. So in this case, this is the some fundamental kind of thing. I am selecting the diversity factor. But if you are constructing the plant, then you already know when this motor will come, when this operation will come. Then the demand factor will be there. Like similar case, but you know there when this motor is running. Let's see, show you, give me a minute. Able to see this screen?
Yes.
Yes, sir. So here you can see, suppose this is the one motor, okay, which is 3.3 kV motor, and the power is 650 kilowatt. So what is the power of this motor? 650 kilowatt. And based on this, I calculated the rated current. And power factor is this. And efficiency of the motor is this. But if you see the load factor, it is like demand factor only. Demand as a load factor, which is 75. Well, how I got the 75? So based on the operation of this, maybe it is loading 75% of the 650, or maybe during the cycle, it is only occurring 75% of the period. It is occurring. So that is 75. Two cases. If you think that, suppose I am having a 650 kilowatt of motor, but is continuously loading only 75%. That is the one way of doing, one way of thinking of 75%. Other one is if you are having some period of time, then what is the case? That is also similar to this factor of load factor. Suppose I'm taking a 12 hours duration. In that 12 hours duration, it is only coming into the play only for 6 hours. Then the demand from this motor is only 50%. And in the other way, I don't know the cycle here. So here I will talk with respect to the connectivity for the auxiliary transformer sizing. This motor is generally operating, even though I am placing the motor for 650 kilowatts rated capacity, it is running at the load of only 75%. That is a load factor. That is also a demand factor in other way. So how much load it is contributing to the entire system? Here it is 75%. So 650 into 75, this is my capacity required for this particular load. Similarly, you can see the loads. You can see the pumps. There is 9. This is a kind of a based on the diversity factor also. How the operation here? I know this. I know the operation of this. That's why I'm calling that as a load factor. If I don't know, suppose for the lighting loads, I will take a diversity factor of 0.9, guys. That is the other case. So I calculated all these things. Now it seems that the load I required is only 4776. This is my load, but my connected load is obviously more than this, which is 12.5 kilowatt. They are already given here. 12.5. If you add all this, you can find this. But my connected load is only this, not this. Sorry. If you add this, it would come to some value. So this is my normal load for this switchgear. And similarly, I'm having one more switchgear, and I load these loads are 4543. So if I am adding the both, I am getting some margin 9320. This is my maximum demand of the system. But what is my connected load? The connected load is, if you all do this, then I will get the connected load. This is my maximum demand. What is the total connected load? This is a total connected load. Understood?
Yes.
Yeah. So maximum demand is different. Total connected load is different. So what is the total connected load? I placed a 5 kilowatt machine, but it is operating at 4 kilowatt only. The supply, the needed power is. That is a connected load. 5 kilowatt is the connected load. 4 kilowatt is the maximum demand. So I am calculating the maximum demand from this by placing all the loads. So this we will call as a load schedule. From the load schedule, what is the output I will get? What is the maximum demand of this? Here the maximum demand is 9320 kVA. This is my maximum demand. Now taking this maximum demand, I have to calculate the transformer sizing. So generally what you will do? You will size the transformer. You will size the transformer. You know the maximum demand. What you will do? Okay, what is the maximum demand? 150 kVA. Okay, I will select 150 kVA auxiliary transformer. Or suppose if you want to take margin, let's 1.1, use 165. So let's take 165 kVA auxiliary transformer. This is my design. Absolutely fine. So this approach we will call as a steady state approach. This we will call as a steady state approach.